Okay, so we're ready for our first trigonometry problem. Let's dive right into it. Okay, so we have a vector here that has a value of 15 and it's on an angle of 60 degrees. Okay, so the first thing I'd like to do is let's describe the direction that the vector is going in. Would you say that the vector is going in the direction of up and to the right, up and to the left, down and to the right, or down and to the left? Most of you actually would hopefully correctly say, hey, it's going up and to the left. We know that the vector is going to the left and it's going up. These are the two component vectors that we'll have here. And being that we see that's going to the left, we're just going to call this x, and the vector that's going up, our component vector, is going to be y. And just keeping in mind here that we have a right angle over here. So we know that we're capable of using trigonometry in order to figure out the x and y components of this vector. So, very first thing that we need to do is let's identify the different parts of the triangle. Which part of the triangle is the hypotenuse? Hopefully you're saying the 15 is. Okay, what about the opposite side? Because it's the side that's farthest away from the reference angle. And what about the adjacent side? The side that's next to or touching the reference angle. Okay, and that honestly is the hardest part of these trigonometry problems. Everything else is pretty simple. So what I want to do is just notice, hey, you know what? This is our given piece of information along with our reference angle. So we want to be able to work with our given piece of information. Hey, notice these equations over here. We are given our hypotenuse in the sine equation and in the cosine equation. Would it make sense at all to actually use the tangent equation? No, because we have two unknowns in this equation, and it just wouldn't make sense to use that. So, which side do we want to solve for first? Doesn't really matter. Let's find the y component of this vector. So that being the case, we're dealing with our opposite side and our hypotenuse. So which one do we use? Hopefully you're saying to yourself, hey, you know what? It would make sense to actually use the sine, being that deals with the opposite and the hypotenuse. So let's write that out then. So we have our sine of the reference angle is equal to the opposite over the hypotenuse. I always like to write out the equation first and then plug in from there. Trust me, I've seen this time and time again where people are like, oh yeah, you know what? I don't need to actually write the original formula. Yeah, I could just plug in right away. I see people make mistakes so much, and it's such a silly, just unnecessary mistake to be making. So always write out the formula first and then plug in from there. So it's the sine of the reference angle, which is 60 degrees, is equal to the opposite. Hey, that's our y. Divide that by our hypotenuse, which has a value of 15. Notice here from the do now that we did before, we're capable of solving out for our y. How do we go about doing that? Multiply both sides of the equation by 15. We're multiplying 15 to the sine of 60 degrees. We're not multiplying 15 to 60. We're multiplying 15 to the sine of 60 degrees. These two cancel out. And if you have yourself a TI calculator, Texas Instruments calculator, you could plug this in and we could get our value. So I'm just going to do that right now. Oh, the one thing I do want to make sure that you have an understanding of is talk to your math teacher or your physics teacher and make sure that your calculator is in degree mode and make sure that's not in radian mode. You have to keep that in mind. If you don't put your calculator into degree mode, you will get this problem wrong. Okay, and I got an answer here of 12.99. Now, let me ask you this. Right off the bat, does this value make sense? And you're like, hey, you know what? How would I know? I've never actually done trigonometry before. How would I know that a value of 12.99 makes sense? Well, let me ask you something. What do we know about right triangles? We know that the hypotenuse should be the longest part of the triangle, which is a value of 15. being that we got 12.99, a value that's less than 15, does this value make sense? And I'm sure you could actually say, hey, you know what? It actually does. That does make sense. If we got a value of 15.00000001, that doesn't make any sense because we know that by definition, the hypotenuse is the longest part of the triangle. So the value of 12.99 does make sense. Okay, so that's the value for y. Now let's try to find out what x is equal to. And we're going to be using our adjacent. The thing that I don't want to do is this. So we have our given information is the hypotenuse and the 60 degrees, which is the reference angle. I don't want to use this value here because say if we got this wrong. I know that we didn't, and we actually already logically double-checked to see that it does make sense. But what if we actually got that wrong? Do I really want to use the adjacent and the hypotenuse, the answer that we derived? You know what? Let's play it safe and actually just use the given information. So I'm just going to use the adjacent and the hypotenuse. Okay, well, coming back over here to the right-hand side, looking at our sine, cosine, and tangent formulas, which one of these actually makes sense? So we are given our hypotenuse, that's given information, and we're looking for our adjacent. Hey, you know what? Our cosine has to do with the adjacent over here. So it makes sense to actually to just be using that. So once again, we're just going to rewrite the formula of cosine theta is equal to adjacent over the hypotenuse. So cosine of theta, which is our reference angle, is equal to the adjacent, which is x, divide that by our hypotenuse, which is the value of 15. How do we solve out for this? Multiply both sides by 15. Once again, we're multiplying cosine of 60 degrees times 15. We're not multiplying 15 times 60 and taking this cosine of that. That's not what we're doing. We're multiplying 15 times the cosine of 60 degrees. I really want to emphasize that. Okay, and these two cancel out, and we should plug this in the calculator, and we'll get a value of x is equal to 7.5. Okay, this answer is good, but not perfect. Well, wait a minute. Why is it not perfect? Why is this answer good when we solved that for y, but for solving for x, hey, you know what? This answer is good, but not perfect. Well, once again, consider the idea that these are the component vectors. So what does a vector have to do with? It has to do with magnitude and direction. How do we go about showing the direction of this vector x? Giving a minus sign. This minus sign indicates the direction. And I really should be putting here that these are vectors. I should have done that to begin with. I apologize for that. So that's the value of this vector.